I'm Nigel Chivers. I'm really concerned about the environment, and I'm really concerned about what's going to happen to our future generations. So much so that I've been doing a lot of research lately on the rising sea levels. And I thought I'd pass on this information to you because the more that you know about this, the more that you can do about it. So I did a lot of reading. This is essentially what's happening. Oceans have been rising since the beginning of the 1800s, and from the 1800s to now, the ocean has risen 9 inches. So that's 9 inches. So not a whole lot. The ocean, when they measured it in 1900, per year was increasing 1.4 millimeters. So again, not a huge amount. But now, when they measured it just in recent times, the last couple of years, they've seen that the actual increase per year is 3.6 millimeters per year. So 3.6 millimeters per year. So that's actually a 2.5% or 2.5 fold, 250% increase. That's huge. So to actually look at the severity of that, it's increasing exponentially. It's increasing every decade. It's increasing quite a lot. So going along with what's actually happening over, say, the last 25 years, what's happened in, that's when the majority of the 9 inches happened. And what was it from? Was it from like melting ice? Was it from glaciers? Was it from rivers going in? Well, they've actually figured out what that was actually due from. So it's actually fairly surprising. Thermal expansion. Thermal expansion is when water increases in volume, because the actual densest water can be as 4 degrees Celsius. As soon as it gets just a little bit warmer, it actually increases, and it increases its volume substantially. So when we have a whole lot of global warming, as I talked about in our last video, and all due to the carbon fuels being burned, greenhouse effect, the overall temperature of the world goes up, and that drives thermal expansion. And 25 years, 42% of all that 9 inches was due to thermal expansion. Surprisingly, glacial melt, Antarctic melt, and Greenland melt were the other significant factors. It's not like a river going down into the ocean. It's actually the actual glaciers themselves melting. Glaciers themselves melting actually contributed 21%. The Antarctic contributed 8%. And Greenland, which is Greenland and Antarctica, where the two biggest ice sheets are located. And when they melt, they make quite an impact on the overall level of the ocean, 15%. And something that totally surprised me was the Arctic. The Arctic, which is all that frozen water and it's all melting just as fast, doesn't make a difference, because sea ice, when it melts, doesn't increase the volume of the overall level of the ocean. It's already very expanded. It's not dense. When it goes down into the water, it actually ends up that the level of the water is not actually increased substantially, because it's actually becoming a little bit less dense. You can prove that when you get a glass of water, you just put an ice cube in it and then measure it before and after the ice cube melts. It doesn't really increase. So this is what we have right now. So what happens when all of the ice melts, the Antarctic and Greenland? Because that's where most of the ice of the world is located. Roughly 90% of the ice, 70% of the fresh water is located in Antarctic and Greenland. So when they melt, that's going to be the big effect. So if Antarctic was to melt 100%, we'd be drowning. 188 feet was what the ocean would go up. If all of the ice in Greenland was to go up, that would be 23 feet. So there you have it, is where the major amount of increase in the level of the ocean is rising in the past, and in the future what's going to happen. Well, we know that if all the ice melts, we've got basically 211 feet that the level of the ocean is going to go up, and plus there's going to be some more glacial melt and more thermal expansion. Now the prediction is that it's not going to be 50, 100, 1,000 years. It's going to be 1,000 plus years minimum of when all this is going to happen, and it may never happen if temperatures get back down to where they hopefully should be. But let's look at the relevancy of what's in the next, say, century. We will look to see what happens in 2100. That's going to be a lot more relevant to you and I, because that's going to be our kids. So let's take a look at what the prediction is. And you can see a lot of predictions which are always saying the same thing. 6.5 feet by 2100. So pretty concerning, because when you look at that amount, that actually puts a lot of the coastlines of the world underwater. Looking at that just a little bit more carefully, this is a really great graph, and it's saying that we're at a decision point right here. And if we end up with doing everything we're supposed to, the Paris Accord, doing the lower emissions and that, we may at the end of the century only go up a foot. But that's really, really unlikely. If we do everything as we're doing right now and don't make a change, and we continue on the path that we're going, it ends up that it's up here. That is the worst case scenario. It's almost 8 feet. So 8 feet, 1 foot. That is why we really have to start taking note of where we are at present and start making a difference today. One more thing that you might panic about. I found this really great pictorial online, and we're right down here right now, and we're at a point where Venice is already underwater a little bit. Places like coastal cities, Richmond, BC, a lot of them are just at the point where we're at zero sea level. So if the sea level goes up 8 feet, you realize that wipes out Venice, Amsterdam, Hamburg, St. Petersburg, Los Angeles, San Francisco, and Lower Manhattan, just to name a few. So it's panic city now. We got to do something, and we got to make a plan. So I thank you for watching this video, and hopefully you understand a little bit about what's going on with the levels of the ocean getting higher. Thanks for listening. Bye-bye.